Okay, for this exercise, we are going to do another module on sea ice, but it's going to be on the actual daily records. And these records are daily. And so we're going to go back to our data source, which is the National Snow and Ice Data Center.org. And that's what we're going to be using. Here's what the website looks like. Again, we're going to come down here and we're going to take a look at sea ice. You can click on that and we're going to explore sea ice data. And again, we're going to be using the sea ice index. And again, here's a little bit about that. Here's a citation, all that sort of stuff. And if we want access to data, you come down here and you click on this file. Here's north, south, some sea ice analysis. Let's see what's in there. Yeah, maybe you don't need that right now. But if you go to, say, north, let's go to daily. You can take a look at some of the images that they have. So, for example, if we go to 2024, in January, you can see what the image of sea ice is, concentration on January 1, 2024. So what the sea ice index does is add all these sea ice areas up and gives them to you as one number. So you can take a look at those at different months, different years. But we are mostly focused on the data here, and this one, we're going to use this North Sea Ice Extent Daily Data .csv. Again, if you click on it, it's downloaded as a CSV, but we're going to go ahead and just copy the link by right-clicking on this, and we will copy the link address, and let's go ahead and put this in here. So that's the address we're going to be using, and so let's just, now what we're going to do is we're going to read this in. So let's make an object called arc. In fact, maybe let's give ourselves a note here. This is reading in Arctic Sea Ice Index record. These are daily values from 1978 to present. It's a pretty awesome record. So let's do read.csv again, and our file, oops, take this code out here, our file, we're just going to copy and paste this thing, and we're going to put it right on the inside of that. And for this particular file, you're going to see that we are going to skip 2 lines, and our header is going to equal false. And let's go ahead and take a look at that. And if you actually open the CSV file, you'll see that. And again, just like we did before, let's just go ahead and click on this, and you can see here's our year, month, day, here's sea ice extent right here. Let's go back to our code. So one thing you'll notice is that, in fact, if we look at this again, before we actually had day of year, but now we actually have year, day, our year, month, and day. And humans keep time in all sorts of different ways, and so we have to figure out how to turn this into a time series that the computer will actually understand. And so we are going to just select the first 4 elements . 4 columns of arc. So these are year, month, day, and sea ice extent. We're going to get rid of that other stuff. So the way we're going to do that, we're just going to overwrite. Arc data is just going to be arc, and we're going to select all rows, and columns 1:4 is columns 1 through 4. So if I just put this in here, right, it's just 1, 2, 3, 4. We're going to go ahead and select this. We'll run that. You'll see arc is still here, but now it's 4 columns. year, month, day, here's CICE extent. Okay. So we got rid of that other stuff that we didn't need. So we'll have to make a time variable out of this. So let's this. This case, we need to make a time variable out of the first 3 columns. Okay. So what we're going to do is we're going to paste together those first 3 columns. Let's make an object called arc_time. And we are going to use a function called paste. We're going to paste arc column 1, arc column 2, and arc column 3. And we're going to put a separator in between these, which is a dash. And let's just look at that real quick. Okay. There's our arc time. Go ahead and click on this thing. Yeah, you can see it. Here's 1978. Or what we can do is we can just take a look at the head of arc time. You can see here's 1978 1026, 1978 1028, and if we look at our original arc values, you can see here's 1978 1026, right? That's our first time value, time value, time value. So you can see at first it's every 2 days, later in the record it's every day. And so, right, so there's 14,833 times here that we have. So let's see if we're going to have to do something a little bit more with this so that R understands what it is. And the thing we're going to do is that we are going to use a function called strp time, strip time. So if you do a question mark, so what strp time is, it's date time conversions to and from a character. So we have a character here, right? This is like text, and we're going to tell R how to interpret it. So we're going to come over here and just do strp time, and what are we going to do? We're going to do arc_time, and our format, you know what, let's do this up in, not down here, do it up here, strp time, and in a second we'll assign this to a variable. We're going to do arc time, right, so this thing right here, and we're going to give it a format. So we're telling it what format the text string is in, and this format, if you look through the help, you'll see there are many options. We're going to do year, which stands for 4-digit year, that capital Y does. Stands for 4-digit year, month, day, and our time zone is going to be GMT. So if we do this, you'll see it doesn't really look any different, but according to R, it is now interpreting this as an actual date. As an actual date. So all we're going to do is we're just going to put arc_time right in front of this. And it might seem a little strange to you because we're defining arc time as this, right? We're pasting it, but now we're overwriting it by taking this arc time, putting into this function, and reassigning it the same name, arc time, again. So we're just overwriting it. We're creating it and then overwriting it, making sure we can actually have a time that works for us. So if we run these two things together, now we have this large thing called a POSIX time. It's machine time. Again, 4,833 elements is the same number of rows we have here. So now we have a time series that we can plot against. So let's just make another one. Arc, let's just all this SIE is going to equal, let's just call it a CICE extent, it's just arc column 4. Right, so if we look at arc again, we took these first 3, we made a date out of it, arc time, and now we're just going to take this last column and reassign it this thing called arc CICE extent. There we go. Good. Now we got two things, right? There's 14,833, 14,833, so every time has a CICE value. That's good. And so let's go ahead and just quickly plot these. And arc SIE. All right, okay, so we have all kinds of wiggles here. Again, this is not a climatology, this is many years. And it's going up and down, up and down. That's the season, up and down, up and down, up and down. But then you also see kind of a general decrease. There's some other humps in here, some interesting features, but we're going to clean this up. But before we clean that plot up, we're going to go ahead and read in the Antarctic data set. So here we go. Let's go ahead now, instead of reading in the Arctic sea ice record, just copy this. We're going to read in the Antarctic sea ice record. Oh, it's not from 1989, 1979. Sorry about that. (1979) to present. All right, where are we going to get that data? Well, first, let's just go ahead and find it. So let's go back to our website, and we'll back this up till we get to south, and then we're going to go to daily, and then data, and now we're going to use this sea ice southern daily extent. And let's go ahead and copy the link address and paste that in here. We're going to use that, and then we can use a lot of this same code that we already wrote. So let's just copy this, and let's just call this Antarctic, or ANT, and instead of this file, right, we're going to drop that right in here. And now, right, now we're reading in the Antarctic one. So let's go ahead and do that. Run. Okay, good. And then what do we need to do? We also need to make this. And instead of art, we're just going to call it ANT. So we're going to treat this file very similarly to the way we treated the Arctic file, right? So there's that. In fact, we can take a look at it. Here's our Antarctic. There's our day or year. Oh, 1978. Okay. Yep. I gotta change this. 70. Oops. 1978. Same thing here. 1978. Okay. Just a note. Just changing the notes to ourselves. All right, there we go. We're going to make time variable the first 3 columns. We'll just copy all this stuff and edit it for our means. That's the great thing about code, is that once you write some, you can change it around, change the recipe a little bit. This is all going to be ANT instead of arc, ANT, and this is going to be ANT, this is now ANT, okay. So now we have the Antarctic time, and let's go ahead and plot this. ANT. So what are we plotting? We're plotting the Antarctic time series and the Antarctic sea ice extent. What does that look like? Okay, quite a bit different. Big seasonal stuff here, right? And is that going up and down? Well, we'll see. Right? Looks like there's maybe some downs over here. And let's now think about how we can plot the record of Arctic and Antarctic sea ice extent on the same graph. So this is similar to what we did before. So let's go ahead and start with something we already made, which is our, let's go ahead and start with our Antarctic plot. And let's add a couple things to this to make it look nice. Let's do type equal L. So you'll see when we do this, now it's going to change this into a line. Okay. And what else are we going to do? Let's now do a line weight equal to 2 and run that. That thickens it up a bit, makes it a little easier to see. Okay, and then let's do X label is going to be the date. Our Y label is going to be millions of square kilometers. And let's do a main here. Is daily, oops, put it in quotes. Oops, daily sea ice extent 1978 through present. Okay. What do we got now? Okay. Millions of square kilometers sea ice, daily sea ice extent. Okay, so let's now go ahead and use the points function. Actually, let's just call it lines. And also use the lines function, just like points. Lines adds to an existing plot, and we are going to plot the Arctic. Just grab these two things. Arctic time, Arctic sea ice extent. Let's do a color equals gray. Line weight equal 2. Go ahead and throw that on there. Ooh, okay, so you see the oscillating pattern here, right? Definitely see that. You see the gray inside the black for sure. And let's do this. Now, let's make a legend. Oops. Our X equals, where do we want to put this? I'm going to put this on the bottom right. And legend is going to equal, we're going to concatenate together. First one we did was Antarctic, and the Arctic, color equals, first one was black, second one was gray. Our line equals 2. So let's see what we got here. Oh, let's also do horizontal equals true and box type equals none. Alright, we put one on there. Okay, there's the Antarctic, there's the Arctic. It looks like maybe our legend is overplotting here, so what we can do about that is we can come back and we can adjust this y-axis. And the way that you do that is come back to your original plot, and we're going to add an xlimit command. And before, when it just plotted, it just took the natural limits here. So let's go from, say, instead of what's the limit down here, maybe 2 or 4, let's go from 0 up to 20. Not on the x, sorry, a y limit. Sorry, y limit. So when we do that, you can see that it moves the whole chart up. We might have room for a legend down here then. And we'll add our lines. Yep. And then we will add our legend. Okay, that looks pretty good here, right? So you definitely see here that we have a really big seasonal signal in both of these, right? So sea ice is highly seasonal, but then, you know, it looks like maybe there's some, definitely looks like maybe if I just look at the peaks here, I can see on the Arctic that the line's going down. Also with the valleys here for the Arctic. For the Antarctic, it looks like the lows are maybe starting to go down here, but a lot of it's pretty darn stable. So let's, the way that we deal with that to eliminate these big valleys is to do what's called a month-over-month plot. So if your biggest changes are seasonal, you know, year to year, what you can do is just plot the same month every year and see if you can see some changes. And so let's go ahead and do this. I'm going to put a thing here and I'm going to say, let's go ahead and read Arctic sea ice extent for March and September. So we're just going to pick a couple months. So let's do arc_March, and we want to do a read.csv, and we want our file to equal something, but what should that be? Let's go back over to our website. Okay. Let's go back. I'm going to go to the Arctic. Let's go to North. Let's go to monthly instead of daily. Go to data and see here's now months 1 through 12. So let's pick March. Let's go ahead and copy this link address. We're going to put this in here. Whoops. Yeah, that did it. North extent, right? That's the link address. All right, that's Arctic March, right? Because we have North the 3rd month, so that's March. And we want header to equal true. Let's go ahead and run this and take a look to see what it looks like. Here's Arctic March. Let's click on it. Here's the year. Here's the month. Here's the region. Here's the extent. Here's the area. So what do we do then? Okay, so we don't have to worry about, since it's all the same month, we can just plot the year in this case. So that's helpful. So let's do now the same thing for September. September. We can probably be smart about this. This is North, and we're just going to put the 9th month, just like that. Boom. Okay, there it is. There's Arctic September. There's the extent. All right, that's pretty nice. And we can do the same thing for the Antarctic. Let's copy this note. So yeah, what would we change here? We were smart about it. How would this be organized? Let's do the Antarctic, ANT. Probably this is going to be under, now, not north, but south. And this is going to be south. Let's go ahead and read that. There it is. Antarctic March. Region south. There's the extent. Okay, and you can probably guess what this is going to be for September. Just copy this same thing, And you can pick any month really you want. So we're south, and we just have to say this is now the 9th month. And of course, those files correspond to files that live in this directory structure, which we're guessing correctly in this case, right? We're just going to go back to NOAA, south, monthly, data, and here they are, right? There they are. Updated January 2nd. Okay. Now what we can do is plot these together. Let's go ahead now and plot. We can just borrow this whole plotting scheme right here. In this case, I want to plot ArcMar, and ArcMar, the first column is the year, so that's helpful to me. First column, and I can do ArcMar. What column is going to be helpful now? 1, 2, 3, 4, 5. The extent. 5th one. So let's go back here. 5th. Line sounds good. X lab is going to be date. The Y lab is millions of square kilometers. Now this is going to be monthly sea ice extent. Right? Let's go ahead and plot that. Let's see what that looks like. There's March. Okay, so that would be when sea ice is at its maximum in the Arctic. So why don't we change this to monthly Arctic sea ice extent. Done. Okay, good. Now I want to add September to this. So I'll just copy these two, overwrite this, and I want Arc September. Okay, let's add a line. Oh, unexpected symbol. Oh, I forgot my comma right here. There it is. Now these are maybe a little bit hard to distinguish. Let's change our point character here a little bit. So maybe let's just do PCH equals 20. So we'll do a solid. Oh, we have to turn our type into an O, an overplot. There we go. There we go, I like that. Put some points on there. And let's come down here. Let's change this to points. And type equals overplot. We're going to do points and characters. And our PCH is going to be 1. It'll be an open circle. Oh, didn't copy the whole thing. There we go. That's a little easier to distinguish. So you can see the minimums, right? That's definitely going down. And then what we can do is change our legend bottom left. Now we have, this is now, the first one is Arctic September. I'm sorry, Arctic March. And the second one is Arctic September. Color, black and gray. Yes, and let's add a point character. Our first one was 20, second one was 1. There we go. Arctic March, Arctic September. So some pretty clear decreases there over time. Okay, let's try now. We can do the same thing except for Antarctic. We did all this work here. So let's start with this one. And all we have to do is change this to Antarctic, ANT, because we already have these objects. Date, monthly Antarctic. Right? Oh yeah, let's plot that one. Okay, oh, alright, that one looks like maybe going down there at the end. And let's now take this one. This is now going to be Antarctic, September. At these points. There it is. Okay. Maybe some pretty dramatic decreases there at the end, possibly. And let's now look at our legend. Bottom right, this is now Antarctic March. Take, yep. Black, gray. I think this all works the same. Let's take a look. Yeah, that makes sense. Antarctic March, Antarctic September. So, pretty cool. You can see, I think, maybe some trends. You can adjust the y-axis if you want to see different plots together. But this is a good way to look at long-term trends taking out the big seasonal effect. Don't forget to save your code here. If you hit save, you just want to save your object. You can just say this is test or sea ice records, and you can just save it wherever it is you want. Hit save. That's the best way to do it. You're just saving the code. I'll just cancel this, but you can do it. And then yeah, when you close out, it'll ask you if you want to save. Let's see. It'll ask you if you want to save the workspace image. No need to do that. You just want to make sure that you save your code. And the way that you do that is hit this little save button. Right? You want to save this .r file. Okay.